we have the function f of x equals 4x times e to the 2x to find the interval between -1 and 2. Find the absolute maximum and absolute minimum values of f. So let's take the derivative first. First take the derivative 4x is 4 times e to the 2x, plus take the derivative of e to the 2x and multiply that by 4x. I'm going to factor this out so I can pull out a 4 e to the 2x, and I'm left with 1 plus 2x. Set this equal to 0. 4e to the 2x is an exponential, which is never equal to 0. So I can divide both sides by 4e to the 2x. And so all I really need to do is set 1 plus 2x equal to 0 to get x is -1/2. So now I'm going to plot my number line here. I have -1/2 as my critical number, and then I'm going to close this off from -1 to 2. And now I want to test a different region. So let's say pick a number between -1 and -1/2. We can say -3/4. I know that 4e to the 2x is always positive, so I can ignore that. So when I have 1 plus 2 times -3/4, that's really going to be 1 minus 3/2, which is -1/2. So this is going to be a negative number. Now, plug in a number between -1/2 and 2, let's say 0. Well, 1 plus 2 times 0 is just positive, so that's going to be positive. So really, there's going to be a minimum at x equals -1/2. So we can say that the absolute minimum is at x equals -1/2. And to really find what the values are, what you really need to do is just take the critical numbers, compare it to the endpoints. So if I plug in x equals -1/2 here, I get -2 e to the -1, which is just -2 over e. If I plug in -1, I get -4 e to the -2, which is 4 over e squared, -4 over e squared. Finally, if I plug in x equals 2, I get 8 e to the 4th. So it's clear that when I get two negative numbers and one positive number, the maximum has to be obviously the positive number. That's 8 e to the 4th. Now the minimum we said, just by looking at this graph, should be at x equals -1/2, which is -2 over e. If you're not convinced, you can compare it with -4 over e squared and see that -2 over e is smaller. And that's our answer.